Welcome to Business Math. It is April 23rd, and the party is just about over. We'll finish Chapter 17, which we're going to do 17-2 today, and then we'll do 17-3. On our next class meeting, which actually won't be until Monday. Then we'll skip chapter 18, since we cover that in personal finance. And then we will do two sections out of chapter 19, and then the party is over. So let's go back and review a little bit of what we did in 17-1. We actually talked about, in 17-1, we actually talked about promissory notes. And so if you would like to, you can turn to page 454 to jog your memory, because I'm going to ask you the difference between a promissory note and a discount note. A promissory note and a discount note. Now, which one of those, the promissory note or the discount note, which one is it where the bank actually subtracts the interest before they even give you the money before you walk out the door? So which one of those is it where the bank subtracts the interest before they even hand you the money before you walk out the door? Courtney, which one is it?
The discount note. The discount note.
There's one of them, the promissory
Dr.
note.
D, can you not hear me?
In there in Woodward.
Hello?
Because I can't hear you, Courtney.
The simple discount note.
Let me turn up the volume here. Let's see if the problem is here. Okay, try it again, Courtney.
The simple discount note.
Thank you. The problem was here. It's the simple discount note. So on the simple discount note, the interest is subtracted right up front. So the example that we did on Monday of a simple discount note, let's try this again. It usually takes 2 times. There we go. A simple discount note. The example that I gave is, let's say your $100 is the principal, okay, which actually now correctly is called the maturity value, because this is what's going to have to be paid back. So actually we rename this the maturity value, and the reason we do that is because that's not what you're going to walk out the door with, okay? What you walk out the door with is called your proceeds. So you take the maturity value and you multiply that times, it's called the discount rate. So we still refer to it as the insurance rate, but discount rate is a better term. So if you had a 22% discount rate, let's see, what is $100 times 22%, Rachel?
$22.
$22. So this $22 then, the proper name for that is, and we're assuming this is for 1 year, the proper name for that is the discount, okay? The letters that your author uses for this, they use B for the bank discount, they use M for the maturity value, so this is M, and the discount rate is D, and the time is T. So I had 1 year going on here, so the time was just 1 year. Now the proceeds, that's what you walk out the door with. So the proceeds are equal to the maturity value minus, they're going to grab their interest right up front. In other words, they're going to grab their bank discount right up front. So in this case, how much are you going to walk out the door with, Robert?
$78.
$78 is correct. So you're going to walk out the door with the $100 minus that $22. You're going to walk out the door with $78. Okay? So really, $78 is what you are, is really what you're holding in your hand. So I mean, if you needed $78, that would be just fine. Now, if you want to actually compute your effective interest rate, you have to take the amount of interest, which is actually the bank discount. So the effective rate, this is for the discount, this is for a simple discount note. It's you're going to take your interest, which was your $22, and you're going to divide that by what you walked out the door with, the proceeds, and you're also going to have to multiply that times the time. So if our case, it was pretty easy, so it was just 1 year. We should probably do one more example. I guess you had some in your homework that was not $1. So let's see. We have Shay is gone today, right?
No, I'm here.
Oh, I see. I'm sorry. Shay, do you have your calculator handy? Can you do that for us? 22 divided by 78.
Yeah. It's 0.28.
0.28. So, the effective interest rate is 28%. So this 22 up here, 22%, since it's a discount rate, you're actually being charged 22% on the $78 because that's what you're walking out the door with. You don't get to walk out the door with $100. You walk out the door with only $78. So that's why the interest rate, the effective interest rate, ends up being higher than 22%. So it's actually a 28% interest rate. And on top of that, you had to pay your interest all the way up front. You didn't get to pay it at the end of the loan. So it's not a discount note, simple discount notes. You got to be careful of the fact that you are paying more, a higher rate of interest than whatever that bank discount rate is. You need to know that. Okay. Well, the promissory note, we also talked about that. So if we redo this in a promissory note format, the promissory note there's going to be an amount that you have to pay back. So if you look at the example, on page 454, it's kind of like I promise to pay back $100. That's called the principal or the face value. Now in this case, you are going to walk out the door with the $100 and a promissory note. Then you're going to have the rate. This is the amount of interest that you're going to pay. 22% times the time. Let's just say it was 1 year again. So the actual amount of interest here, it is still $22, but notice the difference. The promissory note, you're actually walking out the door with the $100. So the 22% is actually an honest 22%. Not like on the discount rate where the 22% was not your effective rate of interest. It turned out to be 28%. So this is the actual rate of interest. Now, the amount that you're going to have to pay back is called the maturity value. So in this case, the maturity value, that means the amount you pay back, it's the principal plus the interest. So what is the maturity value in this case, Rachel?
$122?
Correct. $122. So that is the maturity value in this case. $122. Today is the 23rd. All right. Now let's move on. We're going to do section 17.2 or 17-2 now. This is page 457. Hopefully you have your book with you. And online students, hopefully you're looking at page 457. We're going to go back and do some calculations to find the principal, the rate, the time for a simple interest note. And we're going to do also this for a simple discount note. Now, one of the things, if you know algebra, you really don't have to know as many formulas. Like one of the formulas that's just really basic, I'm not a big, you know me, I'm not a big formula memorizing advocate, but this is very basic. That if you want to know what the interest is, it's the principal times the rate times the time. Okay? The interest is the principal times the rate times the time. Now, just to review a little bit of algebra here, how do you solve this equation? Oh, let's say you want to solve it for P. How do you do that, Wyatt?
You divide both sides by P?
That would work. In fact, Courtney the other day did this in a very efficient manner. It's what's really wonderful about mathematics and algebra. As long as you do the same thing to both sides, you're just fine. So if you want to do that as step one, that would be just wonderful. And then what would your step two be, Wyatt? We're solving for P. I'll give you a hint. We don't want the I there, do we?
No, you need to move that.
You want to get P all by itself.
So you want to take... I guess...
So far we have I over P equals R times T, and we want to solve it for P, so we want to get rid of I. How can you get rid of I? How about subtract I from both sides, Wyatt? Does that work?
Alright.
Does that work?
Sounds good.
Ouch!
No.
See, I shouldn't be allowed to trick people at 8 o'clock in the morning, right?
Right.
There should be a rule. Professors should not be allowed to trick their students at 8 o'clock in the morning. So, try again, Wyatt. What do you do to both sides? You want to you can't subtract I from both sides.
You
See,
multiply
because,
it
yeah, you multiply both sides by what?
by I.
All right, well,
Wait.
let's try that. This is
Wait.
the fun part of
Why would you
algebra.
multiply both sides?
If you multiply both sides times I times I is nothing, right? So that gives you just 1 over P, right, up Wyatt?
Uh-huh.
Was that uh-huh or uh-uh?
No.
No, that is,
one of-
I times I is I squared. So that didn't do it. So we don't want to multiply both sides by I. Got to get rid of I.
You divide it by I.
Yeah, divide both sides by I. So if we divide both sides by I, so if we take, or in other words, multiply by 1 over I, which is the same thing as dividing by, pretty soon we're going to come back to Courtney here. She's all ready. And then the i's will divide out. I didn't say cancel, did I? So we have 1 over P is equal to R times T over I. Now we use a property. Here's a property that's a pretty cool property. Here's the property. If A over B equals C over D, then B over A is equal to D over C. All right? That means if you have something A over B equals C over D, let's say this. Let's put an exact, some numbers in here. If 2 over 3 equals 4 over 6, which is true, then 3 over 2 equals 6 over 4. In other words, you can take the inverse, the multiplicative inverse of 2/3, which is 3/2. That's going to be the multiplicative inverse of 4/6, which is 6/4. Which means the multiplicative inverse of 1 over P is P over 1. So P over 1 is just P. And that's equal to the multiplicative inverse of the right-hand side. Now that's like poking yourself in the eye with a sharp stick, isn't it there, Courtney? Courtney she showed us a way to solve for P that was way easier. I'm going to write this back up here, Courtney, and you're going to show us your magic. Solve for P.
Divide both sides by R times T.
Yep, and bingo, you're done. So, now if you really enjoy poking yourself in the eye with a sharp stick, then what you do is you do all that other algebra. The good news is you get the same exact answer. R's divide out, T's divide out, and now we can use the property. Here's the property we're going to use now. If A equals B, then B equals A. That's the property we're going to use now. So we know that P equals I over R times T. All right? So this is why we require algebra for this course. But with algebra, it's pretty neat because it all boils back to one equation. So if you know your algebra, you can even do it with poke yourself in the eye with a sharp stick method, and you'll get the right answer. Principal times rate times time. This is a very, very, very basic formula to compute interest with, and it really hopefully makes some sense. And to make sense out of a formula, a lot of times, this is what I do. I'll take and I'll plug real numbers into here. So I'll plug $100 in for my principal, I'll plug in 22% for the rate, I'll plug in 1 year for the time, and sure enough, you get the $22 of interest. That's how much it's going to cost you. Okay? So this is a really good memory technique to help remember formulas, is take some simple numbers that you understand what's going on. You borrow $100, 22% interest, for 1 year, it's going to cost you $22. Now the advantage of knowing algebra is that you take this one formula, and with algebra, you can solve it just like we did for, well, I don't want to do that. I'm going to do this. I'm going to erase all this part. So with algebra, we came up with a formula for principal, because we divide both sides by RD and then reverse it. We could also, and this formula is totally unnecessary to memorize. The formula for principal, totally unnecessary. Just like the formula for rate. Okay, Wyatt, show us how to solve for R.
I guess you divide both sides by PT.
Yep, divide both sides by PT. More PT, drill sergeant, more PT. That's what we were told to shout in basic training. PT stands for physical training and basic training. So, divide both sides by PT. So here you end up with the formula, which you don't have to memorize. Totally unnecessary to memorize this. That rate is equal to the interest divided by principal times time. That's what the rate is. Okay? In fact, that ought to look familiar because that's how we did effective rate on that with that discount note. Because we had $22 we plugged in right in there. We plugged in our $78 that we actually walked out the door with, okay? And then we had 1 year that we plugged in right there. So the beautiful part of algebra is you don't have to memorize all the formulas. It's really neat. That's why I always got a kick out of it when people go, oh, I never was good at algebra. I just never could memorize all the formulas. No, that's not algebra. I pity the fool that took algebra from somebody that taught algebra that algebra was all about memorization of formulas. Well, anyway, there's another formula you don't need to memorize, and that's the formula for time. Because you can take this top formula, this one right here that I'm circling in red, and you can solve that for t. How do you solve that for t? Jonte.
Divide times R.
Divide both sides. Definitely, you're going to take the top equation and divide both sides by R. Oh, and what else are you going to divide both sides by? Besides just R, Jonte. I'm sorry?
P.
Well, we're solving for t. So you see, we want to get rid of these two right here. See, when we're solving for t.
I said P, Dr. G.
Oh, yes, P. Very good. So you're going to divide both sides by P and R, so you'll end up getting I over PR. So that's how you're going to solve for time. You're going to take the interest divided by principal times the rate. Now what's super cool is all three of these formulas here totally unnecessary to memorize. All right? Totally unnecessary. Really nifty stuff. And in fact, let's take a look at some more formulas that were totally unnecessary to memorize. one of the formulas that your author gave you was this formula right here. This is a formula actually from Learning Unit 17.1. This was maturity value is equal to principal times 1 plus RT. Now, if you look and see, if you analyze this formula, if you multiply this out with the distributive property, P times 1 is P times RT is PRT. Now, hopefully, when you look at PRT, you notice that PRT is the same as what? You know that, Rachel? What is PRT equal to?
Principal times rate times time.
Very good. And principal times rate times time is equal to what entity, Courtney? Interest. So this right in here really is just the interest, which means, see, this is where I do not want you to memorize formulas. I want you to understand formulas, because when you, this maturity value, the maturity value on a promissory note, we're talking a maturity value on a promissory note. This is a simple interest note. The maturity value, in your own words. Now, you can't use the word principal, and you can't use the word interest. So, what is the maturity value of a promissory note or a simple interest note? Go for it, Robert. It's kind of hard to do without. It's kind of hard to do without using the word principal and interest, but see if you can do it.
I would say the amount that you borrowed plus the amount that accumulated that you owe the bank for their money you borrow their money.
That's good. I love it. That's awesome. So this is, it's what you walked out the door with. In other words, what you borrowed. That was good, Robert. What you borrowed. And this was the cost that the bank charged you for borrowing the money. It was the cost of borrowing. So it's the principal is what you borrowed, plus the cost, the bank's cost, or the bank's charge for borrowing that money. And that's what you got to pay back. That's the maturity value. So this particular formula up here that I'm going to circle in red right up in here, that formula hopefully makes sense because it came from, now mathematically we say derived from, but it came from right here. The total amount you have to pay back is what you borrowed plus the bank's cost or the bank's charge for borrowing that money. And I don't know how to emphasize that more clearly than that, because if you understand the basic interest is equal to principal times rate times time. Because what is principal? That's the amount that you're going to borrow. What is the rate? The rate is actually a per dollar. It's actually per $100. So 22% means $22 per $100. That's what a rate is. A 7% rate means we're going to charge you $7 per $100 for the privilege of borrowing money at 7%. So I hope that you are trying to understand this as opposed to just blindly memorize formulas. Because let me tell you something. If you learn any particular skill pretty much by just blindly memorizing, if you put any gap of time between the point at which you learned this material and now you're going to try to retrieve this material, if it was strictly based on memorization, you're going to have forgotten way over here when you put a gap of time in. But if it's based upon understanding, you could put actually a pretty significant gap in time between when you learned it and when you have to retrieve it. And if you totally understood it when you did learn it, you'll be able to retrieve it later. But if it's strictly memorization, good luck with that. Well, bottom of page 457. Now let's walk through the example. That's how we got this formula. It wasn't magic. It wasn't magic. I'm curious, by the way. Raise your hand if you had Saxon math when you were in high school. Anybody have, oh my, I feel sorry for you. And the reason I feel sorry for you, Robert, is because hopefully you had a really good math teacher to make up for the fact that you were using Saxon math. Saxon math is based upon memorize. It doesn't matter if you understand what's going on. Now, hopefully you had a math teacher that helped emphasize understanding, because the true Saxon method is don't understand anything, memorize everything. And I won't tell your math teacher, Robert, but did your math teacher help you understand actually what was going on, or was it strict memorization?
Not so much memorization.
All right, that's good news. That speaks well of your math teacher then. Because I could use any book. I could use a Saxon book. That doesn't matter to me. But you could probably imagine way back in the day when I was a math professor that I emphasized understanding as opposed to memorization. Well, anyway, now you know why. All right, bottom of page 457. Here's the example. Your author is going to use the formula that I just put up, that we figured out where it came from. The maturity value is equal to the principal times 1 plus rate times time. Then your author says, hey, let's just substitute MV for M just to make sure that there's no misunderstanding about variable names. Now that right there, though, to a mathematician kind of looks like M times V. So a mathematician would probably want to just keep it at M, but nevertheless, we better put a time sign in between that R and the T right there, because that to a mathematician looks kind of goofy. All right. Now on page 458, they're going to take the formula and solve it for, in fact, since I can't stand this, I'm not going to substitute the MV for that. Your author says, hey, let's see if we can solve this for P. Now, Courtney, I bet you can solve this equation for P. What do you do to both sides?
Divide it by 1 plus RT.
Very good. Divide both sides by 1 plus RT. So you divide the left-hand side by 1 plus RT, the right-hand side by 1 plus RT. This divides out over here. Answer, principal is equal to the maturity value divided by 1 plus RT. And this formula right here, totally unnecessary to memorize. Totally unnecessary to memorize. By the way, on your final exam, it is open book, open notes, open internet. And if you look on the card inside your front cover, hopefully it's still there. The card, this nice little card in the inside front cover. Kind of a nice card. On the back side of that card, look what it has. It has all these formulas for you. On the right-hand column, it has the simple discount note formula. It has the, it even tells you what page they're on. The desired proceeds formula from a discount loan. So we haven't worked a problem like that. But remember, on the desired, when you did a discount note with $100 at a 22% interest rate, you walked out the door with $78. That was your proceeds. So you can actually end up solving the formula so that you can figure out, hey, what's my desired proceeds? So if I do want to walk out the door with $100, what's my discount note have to be so I can walk out the door with $100? What's the face value of that discount note, which is the maturity value of the discount note? What's that got to be to walk out the door with $100? So that's pretty cool. You can use that for your final exam. I don't care. All right. Well, back to 17.2. We're almost out of time. So your author goes through an example, plugs in the numbers into the formula, into this formula right here, the one I'm circling in red. So your author plugs in the maturity value, plugs in the interest rate, in this case of 6%, and this was 150 days of ordinary interest. By the way, how many days are in a year when you use ordinary interest, Robert?
360.
360 is correct. Well, anyway, then your author does a couple more examples of finding the rate. So you can actually solve the equation that we have. You could solve that for rate, and your author does that. Okay? You could solve that equation for time. And algebraically, you should be able to take this equation or the original, doesn't matter, and you should be able to solve that equation for time. You should be able to solve it for rate. Originally, the original equation was solved it had it in terms of the maturity value. Okay, now I want you to skip page 459 since we're just about out of time. And we're going to do the simple discount note. Now let's examine where this formula came from. Let's see if we can figure out where this formula came from. This is on about 2/3 down the page, page 459. Okay? So, take a look at this formula. P, and your author puts a little sub R on it. I like that. Because actually, it's the proceeds. That's the reason why P with a little subscript R on it right there. Okay? It's not the principal, it's the proceeds. The proceeds are what the money you walked out the door with. Okay? So this is my example of $100, if that was the maturity value, then you got to subtract the $22, which is actually that bank charge or that bank discount. So this example that I had is the one where you'd walk out the door with $78 if this were a 22% discount note. $22 was the bank's charge for the bank discount. That was the maturity value of the discount note, but the $78 is what you not walk out the door with, okay? All right, so now let's take and see if we can derive this next formula, okay? The formula that your author is talking about here is this. The proceeds, it's equal to M times 1 minus D times T. Now, the D times T, let's go ahead and multiply this out and see what we get. Okay, take M times 1 minus dt, and what do you get, Rachel? This is just distributed out. So just start with M times 1 is what?
It's going to be M minus M dt.
You got it. M minus M dt. Now, like before, now D stands for that discount rate. So here's a technique for learning. When you're trying to learn something with all these complicated letters in it, this is how you do this. Start plugging actual numbers into here. Well, let's see, I had $100 there, I had my $22 there, I had my $78 there. So let's see, so what in the world, what is this? Well, this is that discount rate, so that was that 22%. So all of this part right in here, this M times D times T, is actually, that's the interest rate that you're going to be charged, isn't it? Or the interest that you're going to be charged. See, in other words, this was the $100 over here. So all of this, when you take the 100 times the discount rate times the time, this ends up to be the $22. So all of this is actually that bank discount. All of this that I have put in a red box around right in here, that is equal to B, right here. That's the bank discount. That's going to be the $22. So hopefully that makes a little bit of sense. Again, with algebra, you don't even have to memorize all of these formulas, because if it makes sense, like originally, this hopefully makes sense up in here. It's a discount note, so the amount of money that you're going to walk out the door with, $78, it's the $100 minus that bank's charge of $22. So that's it. Well, I will see you again on Monday. You guys did a great job today.
Do we have to come here for roll, or just do the evaluation?
You can just do your evaluation, it'll be just fine, okay?
Okay.
Now, online students, there will be a note at Blackboard of how you do your evaluation. So if you're an online student, then watch Blackboard, and I'll show you where to go to do and the information for your evaluation for the course, okay? Have a great day.